This video series will show you how to convert an Ethereum dApp to the Neo N3 blockchain, so you can take advantage of the powerful features N3 has for blockchain developers like you. By the end of this video series, you will be ready to migrate your dApp to N3 and enjoy the developer-friendly benefits only N3 can provide. Please do the following before watching this video. First, watch the first video in this series to see how the Band Battles game is played. You will find a link to that video in the video notes. Then, go through the Neo N3 basic tutorial for C# smart contract development. It will show you how to install the necessary tools to be able to develop Neo N3 dApps using C# and Visual Studio Code, and will also give you the basic knowledge you need to follow this video series. Ready? Then let's begin. Now that you have gone through the C# smart contract basic tutorial, it's time to start coding. Run Visual Studio Code now. To open a command window inside of Visual Studio Code, on Windows, use the Ctrl plus reverse quote keyboard shortcut. This opens up a command window that we will use now to create and initialize our project. Go to the directory where you keep your programming projects. Create a subdirectory in that directory named neo-band-battles. Go into that new directory now. First, we create a private blockchain using the NeoXP utility create command. Now, we create 3 wallets named Owner, Alice, and Bob using the NeoXP utility. Next, we will transfer 10,000 gas from the Genesis wallet to each of the wallets we just created, so they have some gas to execute transactions with. Neo N3 has the checkpoint tool that allows us to make a copy of our local blockchain. This is a powerful feature that allows us to keep multiple copies of a blockchain in the exact state it currently is in for reuse later, making advanced testing of various blockchain conditions easy and manageable. We will use that tool now to make a copy of the current blockchain. That way, we don't have to repeat the above commands whenever we want a fresh blockchain that just has a few wallets with some gas but no other transactions made against it. Make a directory called checkpoints now so we have a separate place to store our checkpoints. This command creates a checkpoint called basic-blockchain that we can use later. The -f flag tells of the tool to overwrite any existing checkpoint file of the same name. Let's make sure it was created properly. All good. We will create the C# smart contract for Neo Band Battles now. Click on the N3 extension icon to activate it. Click on the button that says Open or Create a Workspace folder to open the project directory we just created for Neo Band Battles. Select the Neo-Band-Battles directory we just created. Click on the N3 extension icon again. Click on the button that says Start Neo Express. This will start a local instance of our new blockchain that we can develop against for rapid prototyping. Type Ctrl plus reverse quote again to hide the command window. It's time to create our smart contract. Click the button labeled Create a New Contract. If you don't see it, scroll down the contents of the Quick Start panel to bring it into view. Then select C# from the drop-down menu presented to us. Enter Neo Band Battles for the name of our smart contract. The N3 extension will create a starter contract for us with some scaffolding code to help us out. If you are presented with a list of choices for projects, take the first choice, which is All Projects. Note, if you see a pop-up at any time prompting you to add missing assets, accept the offer to add them automatically. For example, this screen shows Visual Studio Code prompting us to install the C# extension. If you don't do this, you will miss out on important code editing and running features that make your development efforts easier. Here is the scaffolding code that the N3 extension created for us. I will update the metadata attributes now. Note, it would be wise to use an email address that has strong spam protection and is not vital to you, especially if your code will be in a public source code repository where the spam email harvesting bots can find it. Type Ctrl plus the S key to save the changes. We are ready to begin converting the Ethereum Band Battle Solidity code to C# smart contract code. But first, a brief discussion about persistent storage in Neo N3 smart contracts. There are 2 distinct ways to persist data to storage in C# N3 smart contracts. The first is a replacement for contract-level variables in Solidity smart contracts. Here we can see the Solidity contract level variable named snumGames created as ID. You might think that you can simply translate that variable declaration to a private static declaration in C# like this. But that would be wrong, because unlike Solidity, the variable would not be persisted. C# and 3 smart contracts do not persist contract level variables, not even those declared as static. Instead, contract level variables are completely reinitialized each time an execution context occurs. Note, we will talk more about the big integer type later. Instead, you use the get and put methods that belong to the storage interface. I'll show you how. First, we create a constant to store the name of the variable. By using a constant instead of directly passing in the name of the variable each time, we prevent bugs that might arise due to spelling mistakes. This code shows how we retrieve the current value of the variable from storage using the get method. The first parameter represents the storage area that belongs to the current contract. The storage interface uses a key value storage system. The second parameter is the key to the value we want from the smart contract storage area. In this case, we pass in the name of the numGames created as ID variable. Note the use of the var keyword in declaring the variable that will receive the current value. This tells the compiler to infer the correct type of the variable so we don't have to. Also, note the use of the big integer cast before the get call. That tells the compiler that the value retrieved from the get call should be treated as a big integer value. We will talk more about the big integer type later. Next is the code that shows how to increment the numGames created as ID variable and then store the updated value back into storage. The only difference between the get call and the put call is that the third parameter contains the value we want to associate with the given key. A common usage of persistent storage is to store a collection of items. In Ethereum, this is done by using a Solidity mapping element. In Neo and 3 smart contracts, you use the storage map object for that same purpose. They are both key value stores. Here you can see the smap game ID to game mapping that associates a game struct with its ID, so we can look up the details of a game easily by using its ID. The key is the game ID, and the value is the struct that holds the details for the game. First, we define a constant to represent the collection. Underneath the hood, the storage map object prepends the string to the key passed to every get object and put object method call made off of the object, thus emulating a collection or table. This shows how to construct a storage map object. The first parameter represents the storage area that belongs to the current contract. This function demonstrates how to store and retrieve game detail objects to and from a storage map. We create an empty game details object and set its ID. Then we store the object in the storage map. Now we retrieve the object we just stored. A null return indicates that no object with the given ID was found. Since this should not happen, we report an error in that case. The report error and throw method will be covered later. Now that you have learned how to create and use storage maps for persistent storage, it is time to learn how to navigate them. We use iterators to traverse the items in a storage map. In this segment, we will learn how to build and use them. Here is the private method that will build an iterator that we can use to traverse all the game details objects we have in storage. By encapsulating this in a method instead of duplicating the contained code each time, we eliminate errors that might arise from variances in the construction of the iterator. This method demonstrates how to iterate all the game detail objects contained in our storage map for those. It also shows how to apply a filter too. Each next call returns the next item. The first element in the array is the key and the second is the value. When we built the iterator, we told the find method to remove our prefix from the key by passing it the remove prefix flag. This means that the value returned for the key is equal to the game details object ID. Note the use of the byte string cast on the key field. Because we also specified the deserialized values flag too, the value field is converted to one of our game details class objects when it is assigned to the game details object variable. This line does the filtering. We check the game state field of each game details object to see if it is equal to the playing enum value. If it is, we print its ID to the console with a helpful message. When the next call returns null, the loop exits and we are done. Join our free mailing list to be notified when the first interactive labs for the video series becomes available. Use the link found below in the video notes or visit neobandbattles.com. Neo.